momentum conservation. Okay. If you have two body collision, the momentum conservation, the total initial momentum equals to the total final momentum. If it's a two body collision, it can be written as m1 v1 plus m2 v2 equals to m1 u1 plus m2 u2. So here, we use u to denote the final velocity, and v stands for initial velocity. Okay, so initial velocity 1, initial velocity 2, final velocity 1, final velocity 2. For one-dimensional collision, it's just this algebraic equation. Okay, but if you are talking about two-dimensional collision, they are vectors. So this is actually equivalent to two equations, m1 v1x plus m2 v2x equals to m1 u1x plus m2 u2x. This is m1 v1y plus m2 v2y equals to m1 u1y plus m2 u2y. Okay. That's the two equations you are going to deal with actually.
So the first one is a one-dimensional?
This is general. Because I put the vector side here. One-dimensional is you just get rid of the vector side, so it will be m1, v1, v2. Okay. And if it's three dimension, you are going to get one more equation, right? Or the z component, similarly. For one dimension, you have 1, two dimension, you have 2, three dimension, you have 3 equations. So for vectors, simply you just put them into x and y, z direction. Now, let's look at this problem. We give you the VAVB and UA as the standard vector notation. Okay, and we want to find, in fact, the final speed UB, right? So in this notation, we actually give you v1x, v2x, v1y, v2y, u1x, and u2x directly, right? Or u1x and u1y. You just need to find u2x and u2y, right? So in this case, if we call our A is 1, B is 2. Okay, you can still use UA, UB like this. So what we have is that we have v1x equals to, what's that? What's v1x? 15. And v1y, what's that? Can you tell me what's v1y? 30. What's v2x?
Minus 10.
What's v2y?
5.
5. Okay, and what's u1x?
Minus 5.
What's it u1y?
10.
10. And we want to find u2x and u2y. And finally, from the 2, we can find u2, the magnitude, right? That's what we are going to do here. Any question here? So now, if you put them into the two equations, that's quite straightforward. M1, what's M1 here? 1 kilogram, M2 is 2 kilograms. So 1 times 15 plus 2 times negative 10 equals to 1 times negative 5 plus 2 times u2x. And you get 1 times 30 plus 2 times 5 equals to 1 times 10 plus 2 times u2y. Right? Any question here? So I'm just substituting these numbers. So can you tell me what is u2x from this?
0.
0. Let's check. 15, negative 25. Yes, u2x 0. What's u1, u2y?
15.
15. Okay, I'm not going to check. I will trust you. So 15 meter per second for the y component. 0 for the x component. So what is magnitude or the speed in this case? Simply 15. Okay. Or if you want to do the calculation, it's just square root of 0 squared plus 15 squared, right? Okay, so that's the speed. Any question here? So in other words, if you want to find the velocity, u2 equals to 15 j hat, right? Okay, so two-dimensional motion, it should be straightforward once you realize that you can write them separately along x direction and y direction. But of course, in this notation, all the components are directly given you. Okay, but you need to prepare that. I may give you the velocity for the magnitude and orientation angle, like v1. If I say v1 equals to like 50 meter per second, 30 degree above, like say, positive x. So you have to be able to find out v1x and v1y, okay, by yourself. So that's a vector decomposition.